Okay, let's see if we can't do page 1 front and back, and we'll kind of do these a page at a time. That way y'all can go to wherever you need. Looking at this first one, you're looking at just some of that function information. So when you look at, is this a function or not? Well, if you look right in here, it's not going to pass the vertical line test. So no, this is not a function. Is it continuous or discrete? I can trace it without picking up my pencil, so we're going to go with continuous. The domain, well, you'll notice this arrow is telling you it's going to go to negative infinity. Remember, negative infinity is never going to be equal to. And then it's going to go to the right side. It's going to go 1, 2, 3, 4, 5, 6. And it's a closed circle, so it will be equal to. Range is going to be how low does it go. And I need to take a look at this little piece right here. Those look like they're going down to the same, so I'm going to say -3, less than or equal to y. And once again, this is going to go up forever, so this is going to go up to infinity. Graph the parameter change. So let's talk about, see if we remember what this means. Okay, so insiders lie. So instead of going, remember the inside's always going to be horizontal. This is currently telling you to take your x's. So any x value, let's talk about this x value right here, which is 1, 2, 3, 4, 5, 6. Take this x value, and according to this, it says subtract 2. But remember, insiders lie, so you're supposed to add 2. Okay, so that point's going to move to right there. What I want you to think about is if it's on the inside, and it's adding or subtracting, then it's going to move left or right. If it's multiply or dividing, then it's going to stretch or compress, okay? That would be when you multiply your values. So this on the inside is going to move right 2, and then this is going to make it move up 4. So that would be 1, 2, 3, 4. So that point is going to move to there. I can erase all the rest of this. Then let's just plot a few more points. This right here is going to move right 2 and up 4. So 1, 2, 3. And I'm kind of estimating where this would be. This point right here is going to move 2 to the right and then up 4, 1, 2, 3. So it's going to move to right here. Let's see if we could draw what that's going to look like so far. I got that type of thing. This point right here is going to move 2 to the right and then up 1, 2, 3, 4. So you got this coming here. It's going to go up and then it's going to go up like that. So that's kind of a rough sketch of what it's going to do. The description of this would be right 2. Up 4. Of course, you could get a lot more, fancier than that. It translated 2 units to the right and translated 4 units up. Anyway, so the new domain and range. Well, if it went right 2, that just means add 2 to each of these. Well, negative infinity is still going to be negative infinity. X now is going to go all the way over to 8. If it went up 4, that means add 4 to these y values. Well, if I add 4 to -3, I get -1, and then of course once again infinity is going to stay the same. And you could have looked at the graph to determine that information as well. Okay? The next scenario, I cannot draw points without picking up my pencil, so this would be considered discrete, which means I'm going to have to list the discrete, domain, and range. If you look at these points, none of them are on top of each other, so it will pass the vertical line test, so yes, this is a function. The domain is going to be, let's see, this is -4. This is, what is it, -4, 1, 2, 3, 4, 5, -5. This is going to be -3, 1. I'm just labeling the points right now. And this is -2, 1, 2, 3, 4, 5, 6. This is 2, 0. And this is 1, 2, 3, 4, 5, 6, -2. So moving from left to right, I go -4, -3, -2, -4, -3, -2, 2, 6. And all I'm doing is listing all those x values. To do the range, I'm going to go from the bottom to top, so I go -5, -2. Then I go on to 0, 1, 6. And this is just listing those y values from smaller to larger. This one, insiders lie, so it looks like it's supposed to go right 4, but insiders lie, so it's going to go left 4. And then outside is the good guy, so it's actually going to go down 2. Based on that, that means all of my points, do I have to actually draw this? Graph it, yes. Okay, so left 4, down 2. So this point right here, I'm going to do these just in a different color. 1, 2, 3, 4, down 2. 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 And 1, 2, 3, 4, down 2. Okay, yeah. So that would be the transformation of those points. I just moved them to left 2, and left 4, and down 2. So then I have to write my new domain. Well, to do that, if I went left 4, that means I just subtract 4 from each one of my x's. So negative 4 will become negative 8, negative 3 will become negative 7, negative 2 will become negative 6, 2 will become negative 2, and 6 will become 2. Since I went, and that's the same thing, insider's lie, so it's like you're supposed to add 4, but in actuality, insider's lie, so it's subtract 4. Okay, so then with my y's, I've got to subtract 2, and outsider's a good guy, so we're going to do exactly that. That means negative 5 is going to become negative 7, negative 2 is going to become negative 4, 0 will become negative 2, 1 will become, can't think, negative 1, and 6 will become 4, right? Yes. Okay. Ano mas? This last one, is it a function, yes or no? Yes, it'll pass the vertical line test. It is continuous because I can trace it without picking up my pencil. The domain, the far left would be negative 4, and it is less than because it's open circle. The far right, 1, 2, 3, 4, 5, 6, 7, 8. So less than, this one's closed, so it'll be less than or equal to. The range, the bottom of this is down here, so 1, 2, 3, 4, 5, 6, negative 6, less than or equal to y. Once again, there's no open circle, so that's what it's going to be, it'll be equal to. Then I got 1, 2, closed circle, so I'm going to do equal to. This one is negative f of x. This is on the outside, so it means it's going to impact my y's. And it's saying to take negative 1 and multiply it by my y's. So if I do that, let me go ahead and erase everything I've already written on this graph so it's not in the way. If I do that, all I'm going to do is flip these points. So for example, this is currently 1, 2, 3, 4, 5, 6. So I'm going to reflect it over the x, which means it's going to be 1, 2, 3, 4, 5, 6. Well, this one, this open circle right here is going to land right here. This closed circle is going to land right here at negative 2. This one is at negative 3, so it'll go to positive 3. 0 multiplied by negative 1 is going to stay right there. So let's see if I can put this together. This goes from here to there, to there, to there, and then to there. My board's a little off, so that doesn't look beautiful, but there you go. Then it says, describe it. It reflected over the x. And then we have a new domain. The domain didn't change at all. So our domain will remain exactly the same because the only thing that changed were our y values. So I still got negative 4 less than x less than or equal to 8. My y values, on the other hand, multiplied by negative 1. So if I multiply negative 6 by negative 1, I get positive 6. If I multiply negative 2 by negative 1, I get negative 2. Okay? So now paying attention to my negative 2 is right over here, which will be my equal to. And then my 6 is also, oh, both of those are equal to. Okay? So let's see, what else do we have? Describe the parameter change of this from the parent function y equals f of x. So we're going to start on the inside and work our way out. Insider's lie, so this doesn't go left 7. This is actually going to go right 7. Then we're going to start working our way out. We got negative 2. The negative is going to reflect it over the x-axis. Remember, a negative on the inside right in here is what would reflect it over the y-axis. The 2 is going to vertically, remember it's on the outside, so that's vertical changes. Vertical stretch by 2. And last but not least is furthest on the outside. It's going to shift up 5. Okay? So when you're doing these parameter changes, you start on the inside and work your way out. Use your knowledge of parameter changes to write an equation for each of the following. A linear function that is shifted right 3 and has a slope of -2 from the parent function. So if it has a slope of -2 and it's shifted right 3, there's your slope of -2. There's your right 3. A quadratic function, once again this is going to be the parent is y equals x squared, that is shifted left 1 and down 3. They just basically gave you the vertex, right? -1, -3. So we got y equals, they don't have any stretch or compression vertically, so it goes left 1 and then down 3. Then absolute value function. Remember your absolute value looks like this. So it says this has been shifted up 4 and has been stretched by a scale of 1/3. So if it's stretched on a scale of 1/3, that just means the y's are being multiplied by 1/3. And then it's shifted up 4, so plus 4. Okay? Oh, let's see what we got here. Use graph f of x shown on the left to find a formula for the function g of x. So let's see, I have this point right here, which is at 1, 2, 3, 4, can't count, 1, 2, 3, 4, 5, 6, -6, and 1, 2, 3, 4, 5, 6, 7, -7. That point moved 1, 2, 3, 4 to -4, and 1, 2, 3. Okay? Notice you can see it didn't stretch anymore or anything like that. This goes what? Up 6 and over 4. So if I go 1, 2, 3, 4, 5, is that right? 1, 2, 3, 4, 5. Does that go up? No, that goes up 7. My bad. This goes up 7 and over 4. 1, 2, 3, 4, 5, 6, 7 and over 4. So there's no stretch or anything like that. This is just it moved right and then it moved up. So it went from -6 over to -4. So it moved right. So f of x moved right 2. And then it went from -7 to -3, which means f of x moved up 4. So that would be your transformation notation for that. Let's see. You pull the plug out of a bathtub. The amount of water remaining in the tub and the number of seconds since you pulled it are related to each other. So so gallons in the tub compared to seconds as they go by. So all we're going to do is do a rough graph of this. The amount of water remaining in the tub and the number of seconds since you pulled the plug are related to each other. Well, if it started off with water in it, then I'm up here somewhere, and then as time goes by, it's eventually going to empty. So then it's just whether or not you think, does the water drain out of the tub at the same rate? So you might draw this as I think it's at a constant rate. Maybe you draw it as a little bit of a curve. Once again, you know, that since it's in this scenario, I'd kind of go with just a constant rate, it'd be fine. Might start off a little slow and then speed up. The distance required, or as it starts to get water in it, does it slow down? I don't know, that's all physics. The distance required to stop your car, I'm sure Cody will come up with something for that one. Stop your car and how fast you are going when you apply the brakes. Okay, so the distance required to stop your car and how fast you are going when you apply your brakes. So the distance to stop depends on your speed. If you were going really fast, then it's going to take longer for you to stop. So let's see. If I'm going no speed, then it's going to, of course, take no distance to stop. But the faster I'm going, the more distance it's going to take me to stop. So that would be what a rough graph would look like for that one. And keep in mind, those are just sketches. You don't have to, do a whole bunch of tick marks or anything like that. Okay, absolute values. Let's see if we can remember out what these are. Parent graph in red. Got it. Parent graph in red. Let's see, if I plug in 0, I'll get 0. The absolute value, oh, I better do some negatives in this, shouldn't I? Yep. Let's see, let's do -2. The absolute value of -2 is 2. The absolute value of -1 is 1, 0, 0. 1's 1, 2's 2. Okay, and all I did was plug those in and spit out the y value. That means I got a point here. Remember, absolute value is just kind of like, you know, drawing a line. You start at 0, but then you're going to reflect it over the other side. Okay, so in this case, it's kind of like you have a slope of 1, and then we, oops, got a little off there, and then we reflect it. When you have a slope of 1, it goes to the corner of those boxes. So now what? Parameter change. Okay, so I got to do this, I guess, in a new color. You're going to have a vertical stretch by 2, and it's going to translate down 3 units and right 1. So our new equation is going to be y equals vertical stretch by 2. We got right 1, and then we got down 3. So this right here, this 1, -3, that's going to be your new vertex. So we just go 1, -3. And notice, this point went right 1, down 3. Okay? Now this time, instead of going up 1 over 1, we're going to go up 2 over 1. Up 2 over 1. Okay? And then we're going to reflect those over our axis of symmetry here. So I'll go up 2 over 1. Up 2 over 1. And then this is what I'm looking at. You'll notice this graph got a bit skinnier than the other, so that's what that value out in the front, that 2, is going to vertically stretch it. So let's see, they want the domain for the parent. The domain for the parent is going to be all the reals, because it's going to go from -infinity to infinity. The range for the parent is going to go from 0 less than or equal to y, and it'll keep going to infinity, so you could go ahead and put less than infinity, but you also could have left that as 0 is less than or equal to y. So then we've got our new domain. Well, our new domain, oh yeah, it's going to be exactly the same. And then our new range is just going to change. Instead of the bottom being at 0, now our bottom is at -3. So we're going to say -3 is less than or equal to y. And I could leave it like that, or I could go ahead and put less than infinity too. Starbucks. Gotta love Starbucks. Not for their coffee though. Starbucks brews coffee at an average temperature of 203 degrees. With a 6-degree variance. If there's a 6-degree variance, that means I could get my coffee at 209 degrees, or I could get my coffee at 197 degrees. So we want to write an absolute value equation that can be used to find the highest and lowest temperatures of their coffee. So that being said, equation, that's always important. X, whatever this value is, that starting temperature, we're going to put on the inside. Remember, insiders lie. And then it's going to equal, what's our variation? It's going to be a 6-degree variation. So now we have to solve this. So let's see if we can remember how to do this. To take it out of our absolute values, once we got our absolute values by ourselves, and in this case we do, one of them goes like that. The other one, if you'll remember, has to be multiplied by a negative. So let's see, I got x equals 209, and then over here I got -x plus 203 equals 6. And I got -x equals, if I subtract 203, I get 197. And I multiply across by -1 or divide by -1. Whoops, that was negative. And I get 197. So my solution would be the lowest temperature could possibly be 197, and the highest temperature could be 209, which is exactly what I just told you about 2 seconds ago. Oh, let's stop there, and I'll record another for this group.